Welcome, everyone. Welcome to WestFest 2021. We would like to acknowledge the land that The Ohio State University occupies is the ancestral and contemporary territory of the Shawnee, Potawatomi, Delaware, Miami, Peoria, Seneca, Wyandot, Ojibwe, and Cherokee peoples. Specifically, the university resides on land ceded in the 1795 Treaty of Greenville and the forced removal of tribes through the Indian Removal Act of 1830. We want to honor the resiliency of these tribal nations and recognize the historical context that has and continues to affect Indigenous peoples of this land. WestFest is the Ohio State University's celebration of science, engineering, sustainability, and research. This program is made possible through a grant from the Ohio State Energy Partners. I am Wayne Schlingman, and I will be behind the scenes making sure everything runs smoothly. If you share about WestFest on social media, please use the hashtag #OSUWestFest. We have a few short announcements to share before the program starts to ensure that all attendees have the best experience possible. We are happy to be able to provide captioning for all WestFest programs this year. Viewers have the ability to enable or disable the captions to suit their needs. In order to not interfere with captioning, we have turned off the chat. Instead, we will be using Q&A to communicate throughout the program. The Q&A is down below on your screen. So we definitely want to hear from you. So please feel free to add your comments, questions, and thoughts throughout the program into the Q&A. We will be checking that periodically. Finally, don't forget the digital event passports are available for download from our website. Attend programs, complete challenges, submit your passports for a chance to win WestFest prizes. go.osu.edu/WestFestPassport, no spaces, is the link to go find that. You're attending Magnificent Magnetism, which is being presented by Simon Filbert and Audrey Zinn from Scientific Thinkers. I'm now going to turn it over to them to get the program started.
All right, thank you so much, Wayne. My name is Audrey. I'm the president of Scientific Thinkers.
And my name is Simon. I am the events committee chair of Scientific Thinkers. And today we're going to talk with you about magnificent magnetism, as Wayne said. Started?
Yeah.
We're going to share some slides first so that we can talk a little bit about what magnetism is. And then we will jump right into the fun stuff with our actual demonstrations of magnetism. All right, so the first question is, what is a magnet? So basically what a magnet is it's a special type of metal that can attract other metals. So some metals can be magnetic because of their internal structure. So actually all of the little molecules inside of the magnet is actually what causes it to be a magnet and helps it to attract other metals. So if we have two magnets and they meet each other, they can actually either attract or repel each other depending on which pole of the magnet are coming into contact with each other. So we're going to do a short demonstration in just a second to kind of show you what that looks like in action. So in another demonstration, we're going to show you that magnets and electricity are actually pretty closely related. The reason is that electric currents in a magnet can actually act as a magnet. So if we have an electric current running through, say, a wire, it can actually act like a magnet and have some of the same properties that regular metal magnets have. So with that, that's all of the background information that we need to do our demonstrations. So today we'll be doing two demonstrations with you that you can actually do at home if you want, if you have the right materials. So the first demonstration that we're going to show you is floating paper clips. So in order to do this demonstration, you'll need a ruler, tape, string, at least one paper clip, and at least one magnet. So we'll show you a little bit how that experiment can actually be done at home when we're doing that experiment. The next experiment that we'll be doing is called Homopolar Motor. And for that, all you need is one strong magnet, a AA battery, and some copper wire. And also tape can help for this one. when you're doing these, if you're doing these presentations at home, you should remember that you should have an adult present because strong magnets can actually be dangerous if they're not handled properly. So with that, we'll jump right into our demonstrations. Thank you all for coming.
All right, and as we transition into our first experiment, we're also going to show you magnets right here so that we can kind of get a visual on all of that stuff that we were just talking about. So here we have a magnetized little bar here, and then we have 4 little magnets. And so, like we were saying, with magnets, they either attract each other or they repel each other. And so how we can show that is we can show that here they're repelling each other. So it's actually kind of floating in a way. And the reason for this is because this part of the magnet is, say, north, like 1 charge, versus the other one is opposite, or they're the same, pardon me. This side is the same as this side. And so like repels like, whereas if we were to get a magnet that has opposite, they will attract each other. And so you can have this kind of cool effect with magnets where they seem to bounce a bit because of the various ways that they're repelling and attracting each other. I think that's pretty cool. Are there any questions at this point on the basics so that we can start our first experiment?
I don't see anything in the Q&A yet, but all participants should be reminded that you can type in your questions at any time, and they can be any questions that you think of or comments about what you're seeing in the demonstration. So please type that into the Q&A and we'll get them answered.
Yeah, we'd love to hear any questions, answer your questions, and hear any thoughts about any of the demonstrations that we're going to do. We'll just take 1 minute to set up. We just got to move our demonstration over, and then we'll be right back.
While you're setting up, here is a question in the Q&A. How do magnets actually attract each other? And the next question, which goes right with it, how do magnets repel each other? These are great questions.
Yes, those are great questions. So you can kind of think of these magnets. So actually the way that these magnets work is they set up something called an electric field. So just like on Earth, how we have gravity, right, holding us to the Earth. So if we jump up, then we come right back down because of gravity. You can also think of that as a gravitational field. The magnetic field acts somewhat similarly, right? So actually it sets up a field that can cause forces, and those forces are a little bit different than gravity because gravity is always pointing down, but magnetism can actually change depending on the face of the magnet that you're using. So if you have 2 magnets that are brought together and they have the same poles facing each other, then they'll push each other away. But if you have 2 magnets that are different poles, then they'll pull each other together, just like how, kind of similar to how gravity works. So hopefully with these demonstrations that we're going to be doing, we can talk a little bit more about magnetism and more specifically how it works. It is kind of a complicated topic though. So do you have anything to add for?
No, I think you got it.
Awesome.
All right, well, we'll let them do the demonstrations. If you still have questions, just ask your questions again.
Anytime. So I really like Simon including the gravity aspect because here we actually use both gravity and magnetism. So here what's happening, right, is we have these paper clips, right, and they appear to be floating. How can that be, right? Gravity should be pulling these paper clips to the ground. So what's happening here is we actually have these magnets that are sitting on top of the ruler, and the magnets are attracting the paper clips and pulling them up towards them. But instead, something's kind of tethering them back to the ground. And so with that, we are going to go into our first poll question. What will happen to the paper clips when we take the ruler with the magnets attached away. And so a poll question just went up. Go ahead and answer that with whatever you think.
And I can also read the possible choices that you could have. So the question on the poll is, what will happen to the paper clips when we take the ruler with the magnets away? The first response is the paper clips will continue to float in the air. The second answer is the paper clips will actually change color. The third answer is the paper clips will fall onto the table. And the fourth is that the paper clips will be pulled away by the magnet.
Few more seconds.
Yeah, we'll keep that one open.
Make sure to get your vote in if you haven't voted yet.
Yeah.
Super close.
We appreciate all of your participation in this poll too. And we'll talk a little bit more about each of the answers when we go on.
All right, looks like you are done.
All right, awesome. So do we want to share those results? Perfect. So it looks like the third option, the paper clips will fall onto the table, is the most popular. So I guess we should find out which one it is. Let's just pull the ruler away. And yeah, that's exactly what happens. The paper clips do in fact fall onto the table. So let's talk about why that happens. We know that you have gravity trying to pull these paper clips back down to the table at all times, right? Gravity doesn't just magically go away. But we've also set this up in a way so that the magnets try to pull the paper clips up towards them. And so you have something pulling it up and something pulling it down. And they're arranged in a way that they're perfectly balanced so that they remain stationary. And so when you take that magnet force away, that magnetic force away, all that's left is gravity pulling it down. And so it goes with the biggest force and it falls to the table, which is pretty cool. So we can talk about our second question now. What would happen if the strings were longer? So if we were to give this string right here a little bit more length. Read that.
Yeah, so like Audrey said, our next poll question is, what would happen if the strings were longer? The first answer is the paper clips would get stuck on the magnet to the ruler. The second answer is the paper clips would be pushed away from the ruler. The third answer is the string won't be tight anymore. And the fourth answer is everything would stay exactly the same.
Try to get some answers in.
Yeah.
Anybody else want to give their opinion?
Give us a countdown from 5.
4,
3, 2,
1.
1.
All right.
And
then share results. And it looks like the first option is the most popular. The paper clips would get stuck to the magnets on the ruler. Well, let's find out. We can make these a little bit longer. And that does in fact look like that's what's happening. Yeah, make that one even longer. They're becoming almost flat on there.
We'll actually take this one. Maybe I'll do it out.
Yeah.
We can take this one out.
Yeah, and so what's happening here is there's not enough of a pull. There's not enough space between the paper clip and the magnet to be pulled down by the string. So the magnetism wins, right? Because it gets close enough that it's strong. And once it gets closer and stronger, then it will attach itself to the magnet because it wants to. It's attracting it, right? So yeah.
So I remember someone answered on the previous poll question that the once we take the magnet away, the paper clips would actually go with the ruler. So that actually is the case here because if we take the paper clips, if we take the magnet away here, since the paper clip is no longer attached to the table with tape, then this paper clip can actually still be attached to this ruler, and it's actually stuck on here. So no matter how we move the ruler, this paper clip will still stay attached here because it's no longer attached to the table with the tape. So that was a great response, and I just wanted to make a note that if there weren't tape, then the paper clip would still be stuck to the magnet when we take it away. Show how we set this up.
Yes,
More specifically.
how we set this up, if you want to get rid of the hole there.
Yeah.
So what we did was you tie the string around the paper clip, just like a little knot so that it kind of won't go away, right? And then we put these little pieces of tape, right, onto the string and then onto the table so that it kind of tethers the string to the table, right? And then you can kind of pull the string out of the table a little bit so that it gets to the right length. Separately, we have a ruler where we have these 3 magnets that are taped to it. Because the ruler itself won't be magnetic, but the magnets on it will kind of create that magnetic force. And we raise it up using a bunch of books. Any books will do. And you can also play with this so that it gets a little bit lower, and you can make it really, really high, and it will still work as long as your string is the right length. And so then, oops, that's a little too long. So we adjust the string so that it's just long enough that it will float and not fall. And it takes a little bit of playing around with. Not going to work perfectly the first time. And then our paper clip is flying. And so that's how you set up defying gravity.
Anybody have any questions? I have a question. Does it matter what you make or what kind of material your ruler is made out of when you're doing this experiment?
Okay, yeah, so actually the ruler doesn't really matter that much. So this ruler that we have here is actually kind of a thick plastic. So the ruler itself doesn't have to be metal. It doesn't have to be any specific material. I think that the only thing that matters is that we have these magnets attached. So since we have these magnets attached, the paper clips will be attracted to the magnets, and the actual composition of the ruler doesn't matter. The ruler is just here to hold our magnets in place above the paper clips. So you can do this with any type of ruler, and that's what we were kind of trying to show you at the end, is that you can do this at home with just a few household items like rulers, paper clips, and some magnets. So the stronger your magnet is, the easier it is to make the paper clips levitate, but it can work with less strong magnets as well.
So that's perfect for our first question that we have, which is, will this experiment work with regular refrigerator magnets?
That's a great question. So Audrey and I did try to test this with these smaller magnets. So these aren't super strong magnets. And as you can see, the paper clips, if I can get one, the paper clips still will get stuck to these magnets, but they don't really float in the air that much since the magnet is so weak. So it's better to have stronger magnets. So it's something that you can experiment with. We didn't try it with refrigerator magnets, but I think that it could work if you were able to get your paper clips close enough to the refrigerator magnet.
Okay, so that leads into the second question that I see that relates directly to this, which is, what would happen if you used heavier paper clips?
Heavier paper clips. Well, I
Yeah,
don't think we have heavier paper clips.
Well, would it still work if you put 2 paper clips together?
Ooh, yeah, it should, and we can test that right now. Actually, I don't know if you want to move the tape or whatever, but yeah, we can.
Well, we have to tie them together somehow.
I can see that. Yeah, we'd have to tie them together. That's okay. We can just kind of hold them together. And the answer is, yeah, it should still work. as long as the magnet wants to have both of them. Oh dear, this is a little difficult. Balancing it like that. It should still want to go.
Still want to do it. Okay.
Still wants to do it.
So I think that's a really great question also, because it kind of gets into more how the magnets actually kind of attract the paper clips. So if you have a heavier paper clip, there's actually more metal to be attracted by the magnet, right? So actually the attraction by the magnet will be stronger because there's more metal for the magnet to attract. But also, since the paper clip is bigger and weighs more, it will actually be pulled down more by gravity. So I think that it still kind of depends on the strength of your magnet, but it should work with heavier paper clips. But I think eventually, if your paper clip was too heavy, it would end up weighing too much and it would fall.
Right.
All right, we have two more questions. One is, how are magnets made, and where do you get strong magnets?
Thank you all for your
Yeah,
great
these are
questions. These are
wonderful.
awesome. So that's a great question about how magnets are made, and I don't exactly know the answer to that.
Yeah, I don't think I know the answer to that.
I know that magnets, so I think as I talked about a little bit before, the reason that magnets are magnetic is because all of the little molecules in the magnet are made up in a particular way that makes them either attracted or repelled to other magnets and metals. So the way that magnets, I think, are made is that all of the little molecules in the metal are arranged or aligned in a way that makes them either attractive, that makes them into magnets. So I think if you have something that is very magnetic and you take a metal and you put it near that magnet, then it can actually make that metal a magnet as well.
Yeah.
So it is a little bit complicated, and it all has to do with all of the microscopic properties of all of the particles inside of these magnets, which is actually really cool when you think about it, because something that has to do with everything on the inside actually affects what we see on the outside and actually makes this macroscopic thing which we can see, which is the attraction or repulsion from these magnets.
Yeah. And as for where you can get strong magnets, you should be able to just get them at any hardware store, whether that's like Lowe's or Home Depot, or even it doesn't even have to just be something big name like that. It can just be a general hardware store. Amazon as well. Yeah, you can definitely get those online. But again, if you're going to use strong magnets, please have adult supervision because they can be very dangerous.
Yeah, I was actually the next magnets that we'll be using in our next demonstration. I've actually pinched my fingers a couple of times because when they come together very quickly, and it can actually pinch you. So
yeah,
they can be very dangerous if they aren't handled properly.
Yeah.
Well, that's a good place to pause for just a second while we switch our captioners.
Yeah, we can put this away and start setting up the next one as well.
And as we're setting up, if you want to talk about, because there's two questions that relate to the same thing, is what other metals attract magnets other than iron? And the other question is what types of metals are magnetic? So like what metals do you know of that are magnetic? Or can you use a magnet with?
So that's another great question. So I don't know all of the different metals that are magnetic, and a lot of things that are metal that you might think would be attracted by magnets actually aren't attracted by magnets. So that's something that we'll see in our next demonstration. Yeah, we'll show them. We can show them now.
And that can be a cool experiment to try, right?
Yeah.
Walk around with your magnet.
Yeah,
Yeah.
you can just start putting it up to things and see if it sticks.
Yeah. So this is a type of metal that we'll be using in our next demonstration. This is copper wire. So this is a metal that actually electricity moves through it very well. And it is a metal, so you would think that maybe it would be attracted by magnets. But actually, if you put a magnet up to it, so this is a strong magnet that we'll be using in our next demonstration. If you put a magnet up to it, there's actually not very much effect at all. So it's actually not attracted by the magnets. I think that some metals that can be magnets, I think they typically they are iron or other mixtures of iron with other metals. So things like steel can also be attracted by magnets. And like Wayne said, that's a very great experiment to do, to test that out and see which metals are magnetic and which ones aren't. These magnets right here are called neodymium, which I believe is that's one type of metal that can be strongly magnetic. And a lot of your strong magnets that you find will be called neodymium magnets because that's what they're made of.
So it looks like some other metals that are magnetic include nickel and cobalt. You can try to find some nickel and cobalt in your house. Yeah. And test it out for yourself. Yeah.
Was there any more questions, Wayne, for this demonstration? If not, we'll move on to our next one.
Those are the only questions that we have so far.
All right.
Go ahead and move on.
All right, we're very excited for this one. This one's really cool.
This one is really cool. Okay. So for this one, this.
So our next demonstration, we'll be showing you one of the simplest motors. So if you know what a motor is, it's basically there's motors in cars and things like that. Basically, what they do is they turn one form of energy into another type of energy. So we're going to show you one of the simplest types of those, which is called a homopolar motor. So the way that these work is they use the electric power from these batteries, and using the electric power from these batteries, there's some current, electric current, that passes through and meets over here. And like I said earlier in our little presentation, the flow of electricity, which is called current, can actually act like a magnet to some extent. So we're going to show you how these motors work by just showing you. We'll put these a little bit closer, and then we'll explain a little bit more how you can make these at home. Yeah, these are really cool and they're a lot of fun. I had a lot of fun making these. Audrey and I did.
Yeah. And like Simon was talking about the electric current as we start these, you can think of the electric current as little particles inside of like the battery and then the wire. They're called electrons. You might have heard of them before. They're little negatively charged particles. And what they do is as it moves through the wire, it's moving charge. And so the moving charge, you can think of it kind of like a river where all of the water is moving in one direction and creates kind of like this big like water force, right? And so the same thing is happening here where you have these electric currents inside of these wires that move in the same direction and result in a magnetic force that become very strong. And so the magnetic force of the wire interacts with the little magnets that the batteries are on and causes them to start to spin.
So maybe we'll stop this one.
Yeah, we'll stop this before.
We don't want to spoil anything. So our next poll question is, which of these batteries do you think will make the wire spin the fastest? So actually what you'll see in a second is that each of these wires on top of these batteries will actually begin to spin when we let go. And we'll talk about that a little bit more in a second. But first, I want you all to guess which battery will cause the wire to spin the fastest.
So our poll's been up for a little bit, and I think we have most of our votes in. So if we count down from 5.
5, 4, 3,
3, 2,
1.
All right, everyone ready? We're gonna let them go. They might fall off. They're a little
Yeah.
bit finicky, but
Yes.
we'll let them go and we'll see what happens. You might have to adjust them a little bit
Yeah.
too. You give this one a little kickstart. Yeah, they do get going here.
Yeah,
I
they
think.
do get going.
Yeah, so they fall off the top here and then, yeah. Once they fall off, they don't go anymore, but they really start spinning. And as you can see, we haven't really touched them since we got them going, but they keep spinning. And as long as they are connected to the battery and the battery has enough energy, they'll continue to spin, which is really cool to see. Maybe I can hold some paper behind them so it's easier to see the wire. Yeah, let me give this one a little.
That's like that one should.
Yeah, usually this one's spinning pretty fast. Yeah, right now it actually looks like this one might be winning right now. And this one over here, as you can see, it's also spinning, but since it's so small, the wire falls off pretty quickly.
Yeah.
Yeah, maybe I'll put these here for a few seconds. This one stopped.
So while we're watching these spin, we had another question that can come up, and although it's very much at work with the smallest battery over there, the question is, what is gravity?
What is gravity?
That's a great question.
That is a great question. You want me to answer that?
Yeah, go for it.
Yeah, so gravity is a force. It's basically this invisible pull that you don't necessarily feel at all times because it's always pulling on you. And gravity is the force, the pull that keeps your feet on the ground. So sometimes if you're, jumping up and down, you notice that you immediately come right back down, right? And so the jumping part is you trying to push against gravity. But gravity is super, super strong. And so it's going to win in the end. And it pulls you right back down to Earth. And so then you don't fly away into space. You don't just jump and go all the way up into space and all the way to the moon. And so essentially, in summary, gravity is this invisible pull that the Earth has on you and on everything that you see, so that things stay on the ground. It's starting to go now.
I think we have our answer for which one spins the fastest now.
Yeah.
Yeah.
Yeah, that's
That
something
one-
that's something that's interesting about these because I was doing I was working with these last night and this one was spinning the fastest by far. But then when we made a new copper wire, when we changed the copper wire, this one actually was spinning a lot faster. So as you can see now, it's spinning pretty fast. And this one has continued to spin almost since we've started it, but it's not going as fast anymore.
For whatever reason, it just comes.
Yeah. And then our AAA battery, which is the smallest one, it might be going fast if it could stay upright for very long, but it tends to fall down pretty quickly.
Yeah.
So since we've talked about those for a second, I thought maybe we could explain how you can do this at home. Yeah. So basically, this experiment only takes 3 things. The first thing that you want, if you want to do this experiment at home, is a AA battery. So we have one of these right here, pretty normal. You can probably find one of these somewhere in your house, whether you have to steal that from your TV remote or whatever it is. The next thing that you'll need is some magnets. So here are the magnets we're using. These are strong magnets. They're called neodymium magnets. There's actually 2 of them stuck together here. And since they're so strong, they're actually very difficult to get apart. So you can try very hard to pull them apart and they won't come apart. But for this experiment in particular, it's better to use stronger magnets. So we did try to do this experiment with some weaker magnets, and it seemed to work a little bit, but it wasn't spinning like this. It was quite a bit slower and didn't want to stay going for very long. So for this experiment, it might be better to do bigger magnets if you can get them. The third thing that you'll need, other than the battery and the magnet is some copper wire. So when you get this copper wire, it'll come in like a straight line. And what you want to do is you want to bend the copper wire in a way so that one part of the wire is touching this pointy part on the battery called the positive terminal. And then this part at the bottom, which you make round, should wrap around the magnet at the bottom of the battery. So the shape of these actually doesn't matter too much. You can make it any shape that you want as long as you have one part that's touching the top of the battery and you have this bottom part that's wrapping around the magnets at the bottom of the battery. We made these because these tend to work pretty well for us. And as you can see here, this one's still going. So yeah, this is a good way to make your copper wire if you do this at home. So once you have all your pieces, your copper wire, which you've bent around, and your magnets and your battery, all you need to do is put your magnet at the bottom of your battery. So you have something like this. And then all you do after that is you set your magnet, your copper wire on top of your battery so that it's connected like this. So you have the top of the copper wire on the top of the battery, and then the bottom is wrapped around the magnets. I think it's not going to want to spin right now since I'm holding it, but you give it a little kickstart. After it's on there, it'll start spinning.
Yeah. I can also put this one back on.
These are a lot of fun though. They're very fun to watch and really interesting to play with.
Yeah, you can make lots of different shapes. And again, as long as you have one bit touching the positive part, the top part of the battery, and the other part touching the magnets, you can get anything to spin, any copper wire to spin. You notice they keep falling, they keep, messing up, and that's okay. Things aren't going to work the first time.
Yeah, that's what science is all about, is experimenting and seeing what works best.
Yeah.
And speaking of it, it would be, we do have 3 different types of batteries, but the way that these things spin and how well that they spin actually depends on how well you've made these. So as you can see, this was working before, but now it's not really wanting to spin because it's a little bit bent out of shape now. But you could do things like experiment with how thick your wire is, or other types of batteries, and see how well things spin under those circumstances. So there is a lot of ways that you can experiment with this setup and learn some cool things about homopolar motors.
There is a great question that is in the Q&A that asks, are there any machines that use batteries and magnets in this setup as a homopolar battery or a homopolar motor to do things?
Okay, that's an excellent question. So when I was learning about these homopolar motors, they actually are not very practical as far as like doing any like work. So you couldn't actually like power a car off of a really strong homopolar motor. I think they are good for things like this, as kind of like a little desk toy and for demonstrations to show how the electricity from the magnet, or the electricity from the battery, and the magnetism from the magnets are related to each other. So I don't think that you could use them to power anything, but that's the great thing about science. If you want to, you can learn a lot more about these, and there might be a way to make them usable for things like powering things and using them as an actual motor. So I encourage you to learn more about this and think about that a little bit more. One thing about these though is that the batteries actually get a little bit hot along with the wire. So now that I'm holding these, they are a little bit warm. And the reason that is because there is heat loss from this motor, which is actually a pretty good sign that these setups are not very efficient for being used in a practical sense. But they are very interesting, and they're a great demonstration for showing how electricity and magnetism are related. So I hope you all have enjoyed watching these, because I know I do.
So with that, the question, the next question is how do magnets work in this experiment?
Oh yeah, so what's happening here is you have the magnets working with the battery, right? So the battery is full of electric charge and moving charges from one side to the other. And the magnets work to induce that exact same effect in the wire. And so you have charge that ends up getting moved by the magnet. So like electrons, like I was saying, little particles that are negatively charged, they will get moved by the magnet. And then because they are moving through the wire itself also becomes a magnet. And when you have the two magnets, the wire and the little circular magnets on the ground, because they're interacting with each other, they start to either move towards or away from each other. And the way that we bent the wire, it ends up happening that they spin instead of moving towards or away from each other. Anything else to add?
No, that was great. These are all very great questions.
Yeah, these are
Awesome. Our next question is will this motor work if we used a wire that was made from something other than copper? Does it have to be copper to make this motor?
That is a great question. So that's not something that we experimented with either. So most ways that I've seen this experiment done are with copper wire. And I think the reason for that is that this copper wire, like I said earlier, electricity passes through it very easily. So the electricity from the battery can move very easily through this copper wire, which makes this wire more easy, like it's more easy to turn this wire into a magnet because there's a lot of electric current moving through it. So that makes the copper a very good material to use. You might be able to do something like this with steel wire, but I haven't tried anything like that. I'm saying, okay, maybe not. You wouldn't be able to do anything like this with a steel wire, but it would be interesting to try different types of wires and see how those work. Another thing to look out for when you're doing this experiment at home is the wire that you use has to be bare copper wire. So some of the wires that are sold have this little coating on the outside that's like plastic. And if that coating's on there, then this experiment will not work as well. So you want to try and find wire that is just regular copper wire, and this will work the best.
And then the last question before we have to wrap up is, would you feel a shock if you touched the top of the battery while the wire is spinning?
While the wire is spinning.
That's another great
That's
question.
another great question that I haven't thought about. Maybe we can.
So now we're going to have our students shock themselves and let us know if we can feel it,
Yeah.
or
I don't think so.
It shouldn't. I don't know. I mean, I don't know how we would actually get.
Yeah.
well, even if you touch the wire, because that's touching the top. So if you touch the wire, do you
Don't
feel
do
a
this.
shock?
If you do this experiment at home, please don't do this, because you should be careful when you're dealing with batteries and magnets and things like this. But I don't think it will shock you. And
No, I don't feel a shock.
yeah, the reason is although this battery is electric, the current in this battery is moving through the copper wire, which
On the inside of the copper wire.
yeah. So the reason that it doesn't shock you is because the electricity from these batteries likes to not work very hard to get where it's going. So because the copper wire is easier for electricity to move through than humans are, like human skin, the electricity will move through the copper wire before it moves through your skin. So you won't get shocked if you were to touch the top, like Audrey tested out.
Yeah.
Awesome. Well, thank you, Audrey and Simon. And thank you all of our participants and attendees for coming today. WestFest continues through tomorrow, Saturday, October 16th, with a lot of great programs. There's still time to register for tomorrow and tonight's programs by going to our website, go.osu.edu/westfest. If you have any questions about this event, please feel free to email us at westfest@osu.edu. Again, thank you all for showing up and coming and with your great questions.
Thank you all so much for coming.
Yeah, we appreciate your questions greatly. If you want to learn more about scientific thinkers, we do have our website. I can send it again in the chat, or if someone wants to send that.
I can bring it back up.
That'd be wonderful. That is our website with links about how to get involved in scientific thinkers and more information or anything you want to know. So with that, thank you so much for coming.